Classifying matter. Turn to your pages in the book, 9 through 13. What is matter made of? What is matter? Why is one kind of matter different from another kind of matter? Around 450 BC, a Greek philosopher named Empedocles attempted to answer the question. He posed that all matter was made of four elements: air, earth, fire, and water. Empedocles thought that all other matter was a combination of these elements. The idea of four elements was so convincing that people believed it for more than 2,000 years. Elements in the late 1600s, experiments by early chemists began to show that matter was made up of many more than four elements. Scientists know that all matter is the universe is made up of more than 100 different substances called elements. An element is a substance that cannot be broken down into any other substances by chemical or physical means. Elements are the simplest substances. Each element can be identified by its specific physical and chemical properties. You may already be familiar with some of these elements, such as aluminum or tin. Elements are represented by one or two letter symbols, such as C for carbon, O for oxygen, and Ca for calcium. Go to number 1, apply it on page 9. How can you tell one element from another? You can tell them apart because of their chemical properties. Please record that in your book. Next, number 2, infer. Match the picture on this page of items contain common elements to the element's name. I want you to use different examples for number 2 than aluminum. So the example I'm giving you is aluminum is shiny, silver, and colored, lightweight, and can be bent into shapes. I want you to try to use a different one from up here. Next, atoms. Imagine tearing a piece of aluminum foil in half over and over again. Would you reach a point where you had the smallest possible piece of aluminum? The answer is yes. The particles theory of matter explains that all matter is made of atoms. An atom is a basic particle from which all elements are made. An atom has a positively charged center or nucleus containing small particles. The nucleus is surrounded by a cloud of negative charge. The elements have different properties because of their atoms are different. Molecules. Atoms from most elements are able to combine with other atoms. When atoms combine, they form a chemical bond, which is force of attraction between two atoms. In many cases, atoms combine to form larger particles called molecules. A molecule is a group of two or more atoms held together by chemical bonds. A molecule of water, for example, is made up of oxygen atoms chemically bonded to two hydrogen atoms. Two atoms of the same element can also combine to form a molecule. Oxygen molecules are made up of two oxygen atoms, shown in figure 1. Compare and contrast. How are atoms and molecules the same? How are they different? I have some sentence starters up there for you to use. Both are basic units of blank. An atom is a single unit of blank, but molecule is a group of blank. You can find this all in your reading. Figure 1, atoms and molecules. Use the molecule models to complete the activity. All right, over here I gave you an example. To the left is an example of how to use the next two on the page. Read the directions and try to complete them on your own. So here's your key, and this should also all be in your book. C equals carbon, H equals hydrogen, O equals oxygen, and N equals nitrogen. Carbon dioxide has one carbon and two oxygen atoms. Then you need to try to figure out how that should be written. So CO2 is for carbon dioxide. I want you to try the next on your own. If you need help, ask for help. Next, what are two types of mixtures? Elements and compounds are substances. The most materials are mixtures. Figure 3 shows some common mixtures. A mixture is made up of two or more substances that are together in the same place, but their atoms are not chemically bonded. Mixtures differ from compounds. Each substance is a mixture keeps its own properties. Also, the parts of a mixture are not combined in a set ratio. Think of a handful of sand. If you look closely at the sand, you will see particles of rock, bits of shell, maybe even crystals of salt. A heterogeneous mixture. There are two types of mixtures, a mixture that can be heterogeneous or homogeneous. A heterogeneous mixture, you can usually see at different parts that they can easily be separated out. The sand described above is a heterogeneous mixture. So a salad, think of how easily it could be pieces of lettuce, tomato, and onions, and other ingredients that can be mixed in countless ways. A homogeneous mixture, the substances involved, a homogeneous mixture, are evenly mixed that you can't see the different parts. It is difficult to separate the parts of a homogeneous mixture. Air is a homogeneous mixture of gases. You know that oxygen is presented in the air because you are able to breathe, but you cannot identify where the oxygen is in the air. A loose solution is another example of a homogeneous mixture. Solutions can be liquid, gas, or even a solid. All right, here's some of your examples up here, and I want you to record them in your book. Honey is a homogeneous mixture. As you can see, it's mixed evenly throughout. You can't see different parts separated. A heterogeneous mixture would be an example of guacamole. You can see that each part isn't even, and you can see the different chunks in there. Soy sauce is a homogeneous mixture. Everything's evenly mixed. You can't easily separate each part of it. Is ketchup a heterogeneous or a homogeneous mixture? I want you to answer this one on your own. Separating mixtures. Since the substances in a mixture keep their properties, you can use those properties to separate a mixture into parts. Methods used to separate parts of a mixture, including distillation, evaporation, filtration, and magnetic attraction, are shown in Figure 4. I want you to go through each one of the figures and answer them on your own. This one is either filtration or distillation. Next one, magnet attraction or filtration. Next one, distillation or evaporation. I want you to try to answer these all on your own first. If you need help, ask a teacher. Here's the last one, distillation or evaporation.